Hey, everybody. Welcome to a Minitab Express episode of Let's Play and do some statistics. So you'll notice today that I have a non-data set. Wow, you'll notice today that I don't have anything in the worksheet because everything I'm going to be doing is summarized. So it's been taken out of the data format where it's listed in columns and it's been summarized into a description, and we're still going to be able to do some stuff to it. So I'm also going to show you how to do some t-table values without using a t-table. So there's a lot going on today. So first up, I'm going to take you through how I torture my husband because I made him eat a bunch of candy and keep track of which ones were orange so that we could do this example. So he found, well, he stopped eating after 200. So he found that 109 of the 200 candies were orange. So you may not know this, but even especially candies that have multiple colors like M&Ms, certain colors are more frequent or more common than others. The most common color in M&Ms is actually brown because when they first came out, people wouldn't believe they were chocolate flavored based on their color. Isn't that weird? Anyway, so we're going to calculate a 95% confidence interval for the proportion of all Reese's Pieces candies, which are going to be orange based on this sample. So to do that, I'm going to show you two ways to do it on Minitab Express. The first way I'm going to show you how to do it is using the one sample button. So if you click on that and go down to proportion, we can perform ourselves a 95% confidence interval. So you notice it defaults to you have some data in some columns. Well, I don't have that. But if you click on this drop down, it'll give you the option to change it to summarize data. There we go. And then it quickly changed to number of events over trials. So this is the stuff that you would use to calculate your P bar, or your sample P. So this is 109 out of 200. And then I'm going to click my options. I want to be on 95%. The method we are using is the normal approximation method, so we want to change that up. And then I'm at 95%, so I'm good to go. I'm going to go ahead and hit OK. So again, just to go over the earlier part, remember I want summarized data. I always am putting the number of events, things I'm interested in the numerator, and the number of total attempts or number of trials in the denominator. Let's hit OK. This is also always your sample size in case you haven't caught on to that, the 200. So there is my confidence interval. There's my sample P. I'm going to go ahead and just copy this over to my document. Come on. There we go. And then real quickly, I'm going to show you the other place you can get this from. So if you go back to Minitab Express, if you go up to Statistics and then One Sample Inference, you'll see the option of running a proportion test. And you get the same menu. So just another way to do that. So again, if you just hit Statistics and then One Proportion, there you go. Or sorry, One Sample Inference, because we're just dealing with estimating one point estimate. Okay, so you take a look at that interval, and you ask yourself, does orange represent 50% of the candies in Reese's Pieces? Well, yeah. I mean, remember, this estimates my population parameter is somewhere between 47.569, or sorry, 59 and 61.4. 50 is in there, so it's certainly a possibility. We can't deny it because it's possible. It is possible, possibly, the amount of orange candies, since 50% is in the interval. So I can't deny it. It might be something else, but there's no way for me to tell. And if you're wondering why this kind of question is up here, that's kind of the stuff we're going to be doing next week. You know, is this answer reasonable or not? Okay, so that's a proportion. I know that I'm doing this kind of out of order, but I wanted to make sure I did t stuff before we went into, calculating a t interval. So I want to show you how to get a t value without using the table. So in particular, notice I'm using degrees of freedom here, not sample size. So the sample size for this one would be 21, and my degrees of freedom would be 20. So usually you're given sample size, not degrees of freedom. So to do this, I'm going to go up to probability. Come on. I'm going to go to distribution plot, and then probability display. Sorry, display probability. I always say that one backwards. I did that kind of fast. This is the same menu we used in the previous chapter to do normal probability calculations, and the chapter before that. So you should be pretty comfortable with this guy. However, I'm about to do something you may be uncomfortable with. If we click on that drop down, you'll see there's something on here called T. That's T. Notice it changes its questions to, hey, do you have a degrees of freedom? Yeah, for the first one I have 20. And now here is where you're going to have to be careful. We've been given a probability. I know that I want to be 95% confidence, which means I want 95% in the middle, which means leftover in my two tails of equal size is 5%. I know, I maybe picked this one because it works. So again, it left over in both my tails together is 5%, so I put 5% in this box and go ahead and hit OK. And this will give you my t value. So my t here, is going to be 2.08596. That's more detailed than what the table will give us. So what's kind of nice about this is it is more detailed, so you can be a little more accurate if you use Minitab to do this part. But notice Minitab will do the calculation all at once, so there's no real need to do this. But some of the things in your homework ask you for t values, so here's just a little bit of a faster way to do it. So now I'm going to do the same thing, same degrees of freedom, but I'm going to increase my level of confidence. So I'm going to hit the Make Similar button. I'm going to go down here, and I want 99 in the middle, which means I get 1% in the tails left over. And I'm not messing with my degrees of freedom because it's the same for A and B. And there's my new t value. Notice it is larger. So you might notice that I'm only writing the positive one. Since it's symmetric, the negative one is just the same number with a minus sign up front. So like we usually only write 3 of them. It's just sort of a habit. Yeah, I have nothing else to say about that other than that. Since they'll come out the same, there's no point in it. All right, let's hit Make Similar and do this again. Here we go. So now I want to change my degrees of freedom to 32, slightly bigger sample, which means I'm probably going to have smaller tails. Ooh, and I want to change my P to 90%, which means I'm going to change from a 1% in my tails to 10% in my tails. There we go. Because 10 plus 90 makes 100. Ooh, slightly smaller. 1.69389. I'm just in the habit of typing everything Minitab gives me so I can be as accurate as possible from what it gives me. All right, last but not leastly, what do you think is going to happen here? Degrees of freedom 1,000. That's a huge sample. Yeah, and I want to do 95%. So 5% in the tail, 0.05. Remember, don't do 0.5, that's 50. Are we good to go? Yep. You're probably annoyed with this by now. Oh, look at that. I wonder why I picked this one. Hint, hint, wink, wink. 1.96234. 1.96 is the z value that goes in 95%. Oh, they are perilously close to each other. You may have remembered me during the video saying that t eventually looks like z, and here you go. T is pretty close. So if you look at the 2 for 95, the one with the small degree of freedom is a little bit bigger than 1.96. The same thing is true for D, but D is so close, just so close. You'd probably round it to 1.96. All right, and now for the part I've been waiting for. Let's talk about how you should yell at coffee machines for fun. Anyway, I think I'm crazy. A little more every day. I'm stalling so that if you have not read this question, you have a minute or so to do that and making room for me to actually answer these questions, because these are all pretty typical questions for this. Anyway, so coffee machine, you've already read this. Coffee, yay! So we want to see, is it 10 ounces or are they cheating us out of some coffee? So we've got a random sample, we got a mean and a standard deviation. Let's create our 95% confidence interval. So the first thing it asks us for is the sample mean. I know this seems insane, but it's 9.845. Oops. And I'm going to screw it up for fun. Then it asks me for the standard error. Now, here's the thing. I could calculate this by hand. I could take the, oops, I'm sorry, I hit my mouse, 0.1999 divided by the square root, which is coded this way, of 20. But I just don't feel like it. I want to see if Minitab is going to do it for me. Hint, it does. Actually, no, wait, this version doesn't. Hint, it doesn't. You need to pull out a calculator to do this, which I don't have one handy, and my Mac doesn't have one. This is the best moment in teaching ever. I need to pause this video, and that's hard to do on this version. Come on, Snagit, pause. I'm back. I have stolen my husband's accounting calculator. I hope you find these videos as slightly inconsistent as I do. Anyway, so I'm sad because I was really hoping this came out pretty and it doesn't, but there it is. I did have to calculate that by hand. Minitab does not do it for you, to my recollection on this version, so I was scared. Watch, it'll do it, and I'll be like, whoa! Okay, sorry, that was a little bit too much yelling into the mic. Here we go. I really wish this version of Snag it showed me my sound levels like the old version did, but it doesn't. So let's go to the one sample. So here's where you gotta be careful. I know I'm doing a mean, right? Because I've got a sample mean and I've got a standard deviation. So the question is, am I doing a T or am I doing a Z? And you look back here and you're like, oh, 10 ounces of coffee? That tells me nothing. Damn it. Okay. I just swore. Crap. Okay, 20 ounces of coffee? No wait, 20 cups. Oh, I've got a pretty small sample. But, you know, it's not so small that it's not unreasonable that I couldn't use a Z. And then it hits you. Oh, the standard deviation? It's from the sample of 20. That means I know little s and not sigma, so I don't know the population standard deviation, which means I cannot use z. Gotta be a t. Here we go. Alright, once again it's going to say, hey, you've got sample data in columns, right? Nope. I've got summarized data. There we go. So the first thing it asks you is for your sample size. I've got 20 cups of coffee. Then it wants to know your sample mean. That's that 9.845, which I'm going to type very carefully since I typed it incorrectly previously. Got my sample mean in there. All right. Next up, I want to check my options. All right. Confidence level, 95%. Yep, that's what we want. Let's check our display options. Oh, I don't care what images it gives us. That doesn't matter. So 95%. Double check my values. Looking good in the neighborhood. Why am I rhyming? It'll be okay. All right. Oh, it does give me my standard error for the mean. Oh, it calculates a little. It rounded it for me. I thought it... Minitab 18.3. You really have gotten me all kinds of kerfluffled because I really didn't think it calculated that. Anyway, so I'm hoping you notice there's the standard deviation and then there's the standard error for the mean, which is what I calculated in B because I was really confused and convinced that it didn't do it for this version. It does round it quite a bit though, so you gotta be careful. I did too many places probably. Anyway, so there's my confidence interval. Notice it doesn't give you the degrees of freedom. So C, I actually do have to calculate by hand. I gotta do 20 minus 1. It's 19. All right. And I've got my confidence interval, so I'm gonna put it down here at E. So that's the 9.75, 187 to 9.93813. So we are down to margin of error. So if you remember, margin of error is your test statistic or your some sort of, no, not your test statistic, I just said the wrong thing. It's your critical value. Test statistics next week. It's your critical value times your spread, which we calculated earlier, standard error for the mean right there. So I could use this degree of freedom and the stuff we did in number 2 to multiply, to find the t-value and then just multiply that t-value I get times the spread to get the margin of error. But I'm a little bit lazier than that. So here's a sneaky way to get the margin of error. So to get a confidence interval, you add and subtract the margin of error from the sample value. In this case, it's a mean. It could be a proportion. So I take the mean, I add the margin of error to get the upper value of the interval. I take the mean and I subtract the margin of error to get the lower value of the interval. So just keeping track, mean plus margin of error makes that, which means if I subtract the margin of error from that, or sorry, if I subtract the mean from that, I will get margin of error. So that's what I'm going to do. And this is just like a tricky way to get it. So to get margin of error, which we call little e, which autocorrect wants to really mess with me, we're just going to take the upper part of the CI, confidence interval, and subtract the sample mean. So I'm writing out the equation for this so you'll see where I get my values from as well. You can use this on any confidence interval. You just take the upper value minus the sample value and it'll give it to you, which is kind of nice. This is the other reason I needed to steal his calculator, because I know I'm going to have to type this in there. I'm not willing to do that in my head and get it wrong. Because that's just too many decimals to keep track of. I'm quite certain I will have a boo-boo happen. Or an oopsie. Or whatever you use to mean mistake. I'm sorry. 0.9313. So that's my margin of error. And just a new way to calculate it. Because remember, your sample mean is the center and how you get to the edges of the confidence intervals. values, the upper and the lower, you add and subtract the margin of error. So there's a quick and dandy way to get it from the Minitab output that you have not seen before. So thank you for watching this video. That's one extra thing you learned. All right, so give an interpretation of the answer, the confidence interval that will answer this question. So most people with this at this stage, they'd sit there and say, I am 95% confident that the average amount of the cup of the coffee is between blah and blah blah. Okay, now you sound like a robot. Let's take a look at what we really want to know. Is it 10 ounces? No. In fact, it's below it almost always. So you should look at this and be very angry and upset, like, ugh, it appears my sample evidence actually indicates that the average amount of coffee dispensed is below 10 ounces. I'm peeved because I have been stolen from. We are 95% confident that the average cup of coffee is between 9.93, I'm rounding, 9.94. I missed my W in between. Oh no, where is it in between? Between. But between's a weird word. Judging myself for my lack of ability to speak today. 5 ounces. Yeah, so the machine is shortchanging you. So if you're interested in what they call comptrolling, it's telling and detecting when machines are off. If you were somebody who was interested in that field, you'd be like, oh no, there's something wrong with this machine. Maybe it needs to be cleaned or recalibrated, but it's consistently below what it should be. If you have some spare time this week, the next time you're at a grocery store, go find yourself a 12-pack of a clearish or semi-clear soda or water and sit it on a shelf you think looks relatively level. And if you'll notice, not all the bottles are the same height and fillage. So when they go to test how full their machines are filling, what they'll usually do is measure them in batches of like 8, 16, 24. That's actually what makes the case sizes that they use for most packaging materials and most ounces of bottles, so that they can tell is it on average close enough to what it should be filling. So the next time you look at your 20-ounce bottle of your favorite beverage, it might not actually have 20 ounces in it, but it will on average. Fun fact, you may have been shortchanged. So the next time you're really pinching your pennies and making sure you get everything that you've paid for, make sure that you check all the bottles to find the one that's the fullest. I'm just kidding. Now I'm going to say goodbye. This is probably too long.